Welcome to Abrar Electrical World YouTube channel. I have uploaded already 5-6 classroom type or workshop type during while I was conducting the workshops. On this topic, I have already uploaded those lectures which are interactive kind of lectures and on the whiteboard. So through those, I have already discussed all those things which I have been discussing in another 3-4 slides which are more of a written kind of slides or the presentations. I have taken the help from a very informative, well researched paper which was published and through the teamwork of IEEE and different engineers. So I have posted the first page of that report also on this one so that I highly appreciate and duly recognize the efforts in this paper. I have taken the contents from that paper. Therefore, this is my duty to mention the source as well. My lectures or my slides or presentations, basically I prepare my own slides, my own diagrams, and I prefer to do on the whiteboard with my own writing. But sometimes I take help from various uh, open source material, and these slides I have taken the material from this research paper. So I duly recognize this, and this exercise of mine is purely for the education and training of the junior engineer, the students, and the middle management engineers working in the utility company world over. There is nothing commercial, and everything is for the on the voluntary basis. I've been doing this. I have already uploaded more than 350 lectures, which include academic, but in every lecture I have also included my own experience because I have done system studies for the last 40 years in Pakistan and USA, and I have worked on various power systems during the lifetime, including all I have worked. I have commissioned more than 40 or 50 grid stations, substations, high voltages, GIS, AIS, etc. So this is very essential that whenever you pick up a material from somewhere, we must recognize those papers or those engineers, our colleagues, scientists, etc. That is our moral duty, and we should not use them for any commercial purpose. So with this intro, I would now today cover the power swing protection application. You will say that nothing is new, but it is written in appropriate manner with the help of this paper. You must study this paper if you are hoping to work for MS level or PhD level. This paper will help you a lot in your studies and also as well as in the field. So now coming to the original this topic, that power swing protection application, you will see that what can we do about the power system stability, achievement of power system study, stability study through the use of the various kind of protection application, when to do and what to do. See here, we conduct the transient state stability to identify the location where the power system that imposes limit to angular stability, generators that are prone to go out of step during system disturbances, and those that remain stable. So see, this point I have very clearly explained in classroom kind of arrangement, classroom setting, workshops, and all those have been uploaded. I have drawn the famous parabolic diagram of the rotor angle delta and the power, maximum power, and the horizontal line showing the mechanical power of the generator and the output, the electrical power, which is a parabola. You can go through my those lectures on this topic, like the critical rotor angle, the power angle, the bus angle, the stability limits, criteria for the stability, that I have all done on the whiteboard through the use of whiteboard and the markers, etc. And I have also input all my practical experience in those things. But these slides I have prepared from the paper I have already mentioned. Now, two things here out of step. Out of step means that the generators have a tendency to go out of step, means the angle between them is increasing. There is a certain angle that should maintain a certain angle. The optimal angle of each of the generator is usually 30 degrees, and it may be 45, 35, and they can settle at any different point after the load rejection or the load when there is a load on the generator, increment in the load on the generator abruptly. So they can go out of step means the angle between those alternator and generator is increasing. So that may go out of step. Of the delta angle increases, then a certain limit, then the generator cannot come again in synchronism automatically. So that is known as the unstable power swing, and the system goes into instability, and ultimately there is a out of synchronism tripping of the generators, and you will see the blackouts and the breakdown of the power system. So then there is another application you can do. We can do that. That is the OST, that out of step tripping. Now, out of step tripping means that we deliberately trip the lines or the transformers at certain locations, so that some of the generator who are now going out of the synchronism automatically may be isolated from each other, so that they can come back to a normal rotor angle, and they keep on supplying the load. So what is done? Then the tripping is carried out through the relay setting. As a result of the power system transient state stability, the tripping is fixed at those points, and if you trip the breakers, then the system will be in a islanding mode, and the 2 or 3 power plant can be run with a specific loading. They will not be overloaded due to the power swing or the disturbance tripping, etc. So you can have a power swing blocking for that period also, or you can have out of step tripping as well. It is up to us. Whatever we can want to do, we can do that. And these points you can get from the power system transient steady state stability. I have lecture on this on the whiteboard setting. In the classroom setting, I have uploaded on the islanding of the network. So I have mentioned there that we have been doing the islanding even in the normal operating condition, not necessary in the fault case. To save the system, if all the stations, power plants are running at the brim, and you have unbalance of the power and demand and supply is less and demand is more, then in that case also you can have islanding, and you can isolate the system and run in an islanding mode. So this can be done in case of disturbances as well as in the operation. This I have explained in another video lecture in a whiteboard setting. Now we determine the optimal location of system separation. See, already I have mentioned this. For out of step, saving from the out of stepping of the generator, we can always find the location from the system studies, and then we can separate the system. Then another very important thing is that we can use automatic voltage regulators, and we can use the SVC, the shunt devices, and the FACTS, that is the flexible AC transmission systems, where you can have the shunt power fed into the power system. So static wire system, static wire compensation, SVC, and things like that we can do. So that will also help in the improvement of the system stability. This is an kind of a protection from the going system into out of step, and resulting in the total breakdown or the partial breakdown of the power system. So we also determine the point here at which the systems are going close to the 180-degree away from each other, and you can have a tripping either at this point when the generator is going through the 180-degree position out of phase, and that is known as the trip on the way in. And there is another one is the trip after the swing, that is if the system has passed 180-degree position and then returning to the in phase condition, this is known as the trip on the way out. So this phenomena I have explained in my classroom settings, that how the power swing loci enters into the tipping zones of the relay, distance relay, and it can either return again out of the characteristic, or it can keep on penetrating into the system. So in both the cases you can have the tripping. It is better to have the out of step training, that isolating the system islanding mode. It is better to do it when the system is again returning and it is not 180-degree out of phase. Because when it is 180-degree out of phase, or it is moving towards a 180-degree out of phase, then the breaker duty increases very high, and you must refer to your manufacturer that whether you can do this kind of tripping when the system is going into the power swing is going forward. Means I mean here that the angle is keep on increasing and moving towards 180-degree. So if you go through my slides or my classroom type lecture about the with the heading stable and unstable power swing, there is my lecture on which banner. On the banner you will find written power swing stable dash unstable. In that, this phenomena is completely explained, that what happens to the power swing and how it behaves. So from that theory or from that phenomena, here comes the TWI and TOWO, two term. So please keep in mind, sir, and also study. So one thing I will mention here, that power system study, whether it is steady state or the transient state stability, is not an easy topic, not an easy thing, and the relay setting for the power swing blocking, out of step tripping, out of step, I mean the islanding. So that is not an easy task, and even after many researches and inputs from the field and the theoretical and mathematical modeling, it is a very difficult phenomena in case of a large disturbance to save the lines and to save the power system. This you can always see and read the reports all over the world, that it's not an easy task. And even after studying all this and working in the field of 30, 40, 50 years, you will witness that the system breakdown on the large scale keep on going. So don't get upset. Don't think that it is due to your inability, or you could have done more. Yes, you can do more, but don't think that you can avoid these kind of disturbances, and the result for 100% elimination. There is nothing, because everything is an approximated, an approximation, etc. Mathematical modeling, lot of assumptions, behavior of the governor, behavior of the exciter, behavior of the circuit breaker, behavior of the transmission lines, behavior of the alternators, behavior of the turbine, behavior of the capacitors, the shunt capacitors. So there are a lot of things, and with the complication of the microgrid and the input from the wind and the solar, etc., the problem has become very complicated. So don't think if your system is still going through large disturbances and you are unable to do it, keep on studying, then ultimately you are bound to succeed, but no 100% achievement is possible. Remember this. Thank you very much. Please share our slides. These are free educational purpose series. I have uploaded more than 350 slides for free education of young engineers, students, middle management engineers, etc. all over the world, Australia, North America, Europe, Pakistan, India, Bangladesh, wherever you are, you can be benefited. Thank you very much for listening, and I will keep on my effort for the free education of the engineers all over the world.